Good day, everyone. Today we'll be talking about complex integration. Complex integration is the evaluation of integrals in the complex plane. So we are simply evaluating or integrating a function in complex plane. And of course, the question here says evaluate the integral I equal to the integral from c of z squared plus 2 dz where C is the line, where C is the straight line joining the point Z1 equal to 0 and Z2 equal to 1 plus I. Let's see how we can go about this question. And of course, solving this question will help us understand how we can actually evaluate integrals in the complex plane. So let's get started. They give us that f of z, we have that f of z is equal to z squared plus 2. Don't forget, you always integrate a function with respect to the independent variable. So if we have here, we have that f of z is equal to z squared plus 2 because we always know that integral is of the form integral of f of z dz, where C is the straight line joining the point Z1 equal to 0 and Z2 equal to 1 plus I. So we have that the function f of z is equal to z squared plus 2. But don't forget that z is a complex variable which is equal to x plus iy. Z is equal to x plus iy. If that is true, it means that z1 will be equal to x1 plus iy1 and also z2 will be equal to x2 plus iy2. But they give us 2 points, z1 equal to 0 and z2 equal to 1 plus I. So from the first point, from z1 equal to 0, this implies that x1 is equal to 0 and y1 is equal to 0. Also, from the second point z2 equal to 1 plus I, z2 equal to 1 plus I. This implies that x1 is equal to 1 and y1 is equal to 1, because you can see that the coefficient of I here is 1. So let's see how we can solve this problem. But we have f of z equal to z squared plus 2. Let's put in z equal to x plus iy into f of z. So we are going to have f of z equal to z squared plus 2, and this will be equal to z is x plus iy. So we have x plus iy all squared plus 2. Let's expand this bracket. We are going to have f of z equal to x plus iy into x plus iy plus 2. So we are having x times x will give us x squared, x times iy plus ixy, iy times x will give us plus ixy. Iy times iy will give us I square y square plus 2. So this is what we have. So let's continue. So from here we have x squared, we have x squared, ixy plus ixy will give us 2ixy. Also, don't forget is a I is a complex, I is imaginary, and it is equal to the square root of minus 1. So if I is equal to the square root of minus 1, it means that I square will be equal to the square root of minus 1 square. This implies that because square will cancel the square root, This implies that I square is equal to minus 1. So we have I square equal to minus 1 times y square. This will give us minus y square plus 2. This is what we have. So let's continue. Bring minus y square over to this side. We have x square minus y square plus 2ixy plus 2. This is what we have. And also, if you observe, you're going to see that 2 is a constant, so we can also bring 2 here. We have x square minus y square plus 2 plus 2ixy. This is our f of z. So it means that f of z is equal to x square minus y square plus 2 plus 2ixy. If if z is equal to x plus iy, it means that the z will be equal to the x plus iy. Multiply out, we are going to have the z equal to the x plus I dy. So we can complete the integral I. It means that I, which is equal to the integral of c of z squared plus 2 dz is equal to the integral of c z squared plus 2. Z squared plus 2 is equal to x squared minus y squared plus 2 plus 2ixy. So we are having x squared plus 2 x squared minus y squared plus 2 plus 2ixy. This is what we have. And then the z is equal to the x plus I dy. The x plus I dy. So let's multiply out. We are going to have that I is equal to the integral of c. Multiply out, we have x times x squared times dx will give us x squared dx. X squared times I dy will give us plus x squared I dy minus y squared times dx give you minus y squared dx minus y squared times I dy minus iy squared dy. 2 times dx will give us plus 2 dx. 2 times I dy give us plus 2I dy. 2ixy times dx will give us plus 2ixy dx. 2ixy dx. 2ixy times I dy will give us plus 2I square xy dy. So this is what we have. So let's continue. We have I to be equal to the integral from c x squared dx. We have x squared dx plus x squared I dy. But here we want to separate the real part from the imaginary part. So we are separating the part that does not contain I from the terms that contains I. So we have x squared dx, we have minus y squared dx, we have 2 dx, and we also have okay, nothing. X squared dx minus y squared dx and plus 2 squared dx. So we are going to have x squared dx minus y squared dx minus y squared dx plus 2 dx plus 2 dx. And if you take note, if you observe, I square is equal to -1. So this implies that this part also is real, because if you multiply here by -1, you're going to have -2xy dy minus 2xy dy. So we are done with separating the real parts. One, two, three, four. So let's go for the imaginary parts. We have x square I dy plus x square I dy. The next one there is minus iy square dy minus iy square dy. The next one there is plus 2I dy plus 2I dy. Then lastly, we have plus 2ixy dx plus 2ixy dx. So this is what we have. But notice that we have the x here, the x here, the x here. So we can factor out the x. So I is equal to the integral of c into x squared minus y squared plus 2 into the x minus 2xy dy. We have I here, we have I here, I here, I here, I here. So we can also factor out I plus I into x square, x square into x square dy minus y square dy plus 2 dy plus 2xy dx. So this is what we have. And also we have dy, we also have dy, and we also have dy. So we can also factor out dy. So this implies that we are going to have I equal to the integral of c of x square minus y square plus 2 dx minus 2xy dy plus I into x square minus y square plus 2 into dy plus 2xy dx. So this is what we have. So remember, we can distribute this integral also. So we are going to have I equal to the integral of c x square minus y square plus 2 dx minus 2 dx minus 2xy dy plus I, the integral of c of x square minus y square plus 2 dy plus 2xy dx. So this is what we have. So take note now, we have the integral in the form of x and y. So okay, let's continue. If you take note, we cannot integrate this function directly with respect to x and y. It will be giving us problem. So what we are going to do here, we are going to see how we can convert it to make sure all the terms here are all functions of x. So recall that they give us z1 equal to 0 and z2 equal to 1 plus I. And from here we concluded that x1 is equal to 0, y1 is equal to 0, and also x2 is equal to 1 and y2 is equal to 1. But don't forget that the question tells us that C is a straight line joining Z1 and Z2. So we can actually graph this as we have this plane, and of course, if x1 is 0, y1 is 0, it's simply telling us that x1 and y1 are at the origin. So we have x1 0, y1 0. So we have 0 comma 0. And also x2 is 1, y2 is 1. So we can simply go to the plane. We have x1, x2 is 1, and then y2 is 1. So if you trace this, we have this point. So you see we have a straight line. Sorry, the straight line passes through the origin. We have a straight line that passes through the origin. And of course, this point is 1 comma 1. 1 comma 1. So this is how the graph look like. We have 0 comma 0 and 1 comma 1. So we can find the equation that governs this straight line. And recall that from the equation of a straight line, we have y minus y1 equal to m into x minus x1. So recall from the equation of a straight line, we have y minus y1 equal to m into x minus x1, or y equal to mx plus c. But in this case, we don't have the intercept. So we are going to use this equation y minus y1 equal to m into x minus x1, where m is the slope. And don't forget, slope is given by change in y over change in x, and change in y is y2 minus y1 over x2 minus x1, and this will give us y2 is 1, so we have 1 minus y1 is 0 over x2 is 1 minus 0, and this will give us 1 over 1, which is 1. So this implies that m is equal to 1. So we are going to substitute m equal to 1 to our equation of a straight line. So we are going to have y minus y1 is 0 equal to 1 into x minus 0. And this implies that y is equal to x. So this is the equation that governs this straight line. Y equal to x. So if you differentiate y here with respect to x, you have dy dx equal to 1. Cross multiply, you have dy equal to dx. So we have dy equal to dx. So you see now that it is much more easier for us to put in y equal to x into this equation and dy equal to dx. We are going to have that all the terms there will be in form of x. Then we can now integrate completely. So let's do that. From I, we are going to have I equal to the integral of c x squared minus y squared. We have x squared minus y squared, but we have said that y is equal to x. So it means that y squared will be equal to x squared. So we have x squared minus x squared plus 2 dx minus 2xy dy, but y is x, dy is dx. So we are going to have minus 2x square dx plus I, the integral of x squared minus y squared plus 2. Y squared is still x squared. So we have x squared minus x squared plus 2 dy, but dy is the x, the x. Then the next one there is plus 2xy dx. Y is x, so we are going to have plus 2x squared dx. plus 2x square dx. So this is what we have. So we are going to have that x square minus x square we cancel out. So we are going to have the integral of c 2 dx 2 dx 2 dx minus 2x square dx plus I, the integral of c x square minus x square will also go out. So we have 2 dx plus 2x square dx. So this is what we have. So this means that I is equal to the integral of c 2 minus 2x square 2 minus 2x square dx plus I, the integral of 2 plus 2x square dx. So we can now go ahead and integrate this complete. So, but now we want to find the limit. Since we have succeeded in changing the x and y integral into the form of only x as the variable. So we are going to take the limit from x1 to x2. Don't forget, if you have a function f of x and you want to take the definite integral, you are simply integrating from x1 to x2 dx. This is what we have. So also we are going to integrate this from x1 to x2. So this implies that we are going to have I will be equal to the integral from x1 to x2 of 2 minus 2x square dx plus I, the integral from x1 to x2 of 2 plus 2x square dx. So don't forget that our x1 was 0 and our x2 is 1. So we have I will be equal to the integral from x1 was 0 and x2 1 of 2 minus 2x squared dx plus I, the integral from 0 to 1 of 2 plus 2x squared dx. Let's integrate. I will be equal to, if you integrate 2 with respect to our x, you have 2x. If you integrate 2x squared with respect to x, you have minus 2x cubed over 3 from 0 to 1 plus I into integrate 2, you have x. Integrate 2, you have 2x. Integrate 2x squared plus 2x cubed over 3 from 0 to 1. Please don't forget your integration. Simply use add 1 to the power and divide it by the sum. So we have I equal to, how to take limits? Simply put in the upper limit into the function you integrated and then subtract it from the lower limit. So we have 2 into 1 minus 2 into 1 cubed over 3 minus, if you put in 0 here, you have 0 plus I into 2 into 1 plus 2 into 1 cubed over 3 minus, if you put in 0 here, you have 0. So I is equal to 2 minus 2 over 3, 2 minus 2 over 3 plus I into 2 plus 2 over 3. And this will give us 6 minus 2 over 3, 6 minus 2 over 3 plus 6 plus 2 over 3 multiplied by I. So we have I equal to 6 minus 2 is 4, 4 over 3 plus 6 plus 2 is 8, 8 over 3I. We can factor out 4 over 3. So we are going to have 4 over 3 into 1 plus 2I. So this is what we have. So therefore, I is equal to 4 over 3 into 1 plus 2I. So this is the answer to that very question. And this is how we evaluate integral in complex plane. It means that our integral will give us the answer to our integral will be in the real part and the imaginary part. And we see that the real part there is 4 over 3 and the imaginary part is 8 over 3I. So thank you for watching this video. If you enjoyed this video, please subscribe.